Hi everyone, we're going to now look at applying the numerical differentiation into a question. So I'm looking at question 4 where it says use the values of y of x equals e to the x at x equals 0, 1, half, 3/4 and 1 to estimate the following. So my main focus that I want to do is I want to look at question A, question B, question C, and I'm going to then go straight to question E. I'm going to leave D out because it's very much similar methods to what you're seeing for the previous ones, but I'm going to do E because there's a little bit of complexity that should be noted. So let's start with A. So we're looking to estimate, and let me highlight the important info. We need to estimate this to the order h squared. So first thing to note is it's half. So what we want to be looking at is we're looking at this middle column over here. We want to estimate y prime, so it's the first derivative at x equals half, and it's to order h squared. So generally you'll be starting with central difference. Now, as I mentioned before, important thing of what your O is. So in this case, as you can see here, we're looking at h squared. So that's why I'm looking at the OH squared table. Generally, central difference will be a more accurate approximation than the others. And by default, you're generally going to be working with central difference where you can. So let's consider this. We have the last point we were looking at is it's y prime. So that means that we are looking at this equation over here. Final thing to check is, can we use this formula? So let's say that we were looking at something and we're not sure which formula to use, whether we want to do central difference, forward difference, or backward difference. You've identified your OH squared, you've identified that you're looking for y prime, you'll then look at the equation, and the next thing to check is, do we have all the values given? Now, note as well that in the question, it states, use the values of this equation at these points. So these are the only points we're allowed to use for calculating this. We can't calculate any additional points for determining our approximation. So we have been told we need yi plus 1 and yi minus 1 for this equation, and we need h. Now, h is going to be our difference between each I term. So the first thing to check is, what is the difference between each of these? So if we look at 0 to 0.25, that's a 0.25 difference, 0.25, 0.25, 0.25. That means each of these are, you can consider each of them a difference by h from each other. And what that means is, if we're looking at this term in the middle, that means that if this is our xi, then xi plus 1, well, xi plus 1, as we know by definition, we need xi plus 1 to be equal to xi plus h. So if we see that the difference here is 0.25, we know that h is equal to 0.25. So if our xi is 0.5 and we add h, it's going to be 0.75. So we know that going forward, this fits the criteria for it. I know I've gone through this very pedantically, but it's something that you have to keep in mind when you're doing this, because when you've got your data, they're not always necessarily going to be equally spaced. And sometimes you're going to have to factor that in when you're choosing what your h is. So we know that this will be xi plus 1. So let me just use blue for this. So we know that this is xi plus 1, this is xi plus 2, this is xi minus 1, xi minus 2, and this will be xi. We know that because the difference is equal between each. So, thing we need to consider is, do we have all our points? So we need yi plus 1. We have got, we've got xi plus 1 over here, or just I plus 1 if you will. So this is our xi plus 1. Here will be our yi plus 1. Now we need yi minus 1. Well, we've got that over here. Both these points are given, so we're allowed to use them. And finally, we have h over here, and we know that our h is that over there. Let me just use a quick color for this one here as well. So it's pretty much as simple as it appears. We're going to now substitute into this. So we want to have, let me just get the right tool. There we go. We want to have y prime. So yi prime is going to be equal to yi plus 1 minus yi minus 1 divided by 2h. And in this case, our yi is the same as saying y prime, because we have been told we've set our I to this term over here. So we're looking at y of 0.5. And that is in accordance with what the question's asking. Y of a half, or y of 0.5, which is primed, is going to equal. I'm going to do these in colors as well, just to make sure that it's nice and easy to follow. So we're going to have, I'm not going to enter this into the calculator and get a decimal, because I want to stay as accurate as possible. And also because it's generally easier. So y to the 3 over 4 minus, and yi minus 1 is going to be our dark green, which is going to be e to the 1 over 4 divided by our 2 times our h, which is pale green, which is 0.25. And it's pretty much as simple as that. You punch that into your calculator, and you get 1.6659 and so forth. It's going to be 595, etc., or rounded off to 595. And the interesting point on this, we know that e to the power of x, if we take a derivative of it, because this is our equation here, if we take a first derivative of it, we know that derivative of e to the x is e to the x. And if we check what the actual value is, the actual value, so e to the half, is actually equal to 1.6487 ... And we can see that these are actually very close. So it's always, if you're able to, it's always nice to double check if you are roughly on the right tracks. If you land up with, say, 3 point something when you should be 1 point something, then you know that you need to go back and double check, because you've probably missed something somewhere along the way. But yeah, so it's really as easy as that. I'm going to now cover the next question, which is they want to know y prime prime of 0 to order h squared. So we're going to look at question B. Here they're looking for y prime prime of 0 to order h squared. We get out our highlighter again. We're looking at y prime prime of, I'm going to use green there, 0 to order h squared. So I've already pulled in the relevant tables, because remember, we are wanting the OH squared tables because of the h squared is what we're looking at. So you can see in all these tables, this is the OH squared set of tables. Next thing we're wanting to look at is y prime prime. So we've got our y prime prime there, we've got y prime prime here, and finally over here. So we've got the right tables. We can eliminate all the other equations from consideration. So we can basically cross these out for now. We're not needing the others. So we've cut down our list of equations to 3. Now the next thing that we want to do, we're looking at 0. So if we pull out our highlighter, we've got the 0 there. That means this is what we're looking at. It's this point here. What that means when we're considering this, well, that means if that is our I, then this will be, we know that the difference in x is 0.25 in each case. So this, we know that this can be I plus 1, I plus 2, I plus 3, and I plus 4. In each of these cases, we can consider those to be our I pluses, our differences in I. So, with that in mind, given that these are the only things that we can work with, our I plus 1, 2, 3, and 4, what do we have available here? Because remember, we can't start using ones which we have not been given because it's within the framework of the question. So if we start looking, let's start with central difference because ideally we want central difference is going to be the most accurate. Central difference, well, we've got one color, grab pink. We've got I plus 1. Yes, we've got that. We've got I, we've got that, but then that we don't have. So that means we can't use this equation. Let's look at forward difference. So in this case, we have got I plus 3. Let me get the highlighter. We've got I plus 3. We've got that over here. I plus 2, I plus 1, and I. That means all the different parameters, and obviously we have h squared as well, all the different parameters we've got, so this one we can use. If you were wanting to consider backwards difference, just for the purposes of exercise, we would land at, first of all, we can eliminate that one, but we would be looking at this, well, I minus 3, we don't have. I minus 2 we don't have, I minus 1 we don't have, but I we do have. So we don't have 3 of the terms here, but we do have yi, so we wouldn't be able to use that either. So that was just for the purpose of example. So given that this is our equation, let me quickly just clean it up a little, and that way I can show you what we're looking at properly here. So we have, let me take the highlighter. We've got our term here, blue, let's go red, let's go pale blue, and let's go bright green. So in that case, we will simply input things into the equation. So if we take our equation over here, we will go, I'm just going to write it here, yi prime prime is equal to, let's do a nice straight r. And on top we have yi. What's yi minus yi plus 3. That is pale blue here. So yi plus 3, we land up with e to the 0.75. Remember that it's minus as per here. We have our minus e to the 0.75 plus 4 times yi plus 2. Yi plus 2 is over here, it's in red. So we have e to the 1 over 2. We're going to then have minus 5 times yi plus 1, which we've got in blue over here. And that is e to the 0.25. And finally, plus 2. And we have our green, which is our 1. I'm just going to put that in brackets so that it's clear it's not 21. So these are the terms that have come from our table. And remember, we're dividing by, in this case, h squared. So we have h squared, which from earlier, I mean, I had it in bright green, but I have now used the bright green here. So I will just use purple. So we have 0.25. And that, remember, that's the difference between our h's, our x terms. 0.25 and it's squared. input that into a calculator, and you get 0.924127 412 so I'll put 4128 because it rounds off. And once again, we know that the second derivative of e to the x is still e to the x. So if you work it out, well, e to the 0 is going to still be 1. It's always going to be 1. And 0.92 is very close to 1. So that is doing forward difference. Looking at question C, we've been asked to calculate, let's do our highlighting again. We've been asked to calculate y to the third prime of 1 to order h. So given these, we need to go h. Well, I've pulled in the h tables. There's no central difference table for OH. For the central difference, we start at OH squared. So to order h, this is what we've got that we can work with. So I pulled in these tables. Next thing that we're looking at is y of 1. So when x is equal to 1. In instances like this, just be careful you don't end up looking at the y if you have a similar value there in tests and everything. And finally, y to the third prime. We've got one there and we've got one there. So we can immediately eliminate this, 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 and this. Now, you can be going about this whole process, or alternatively, you can start thinking of it this way. Forward difference requires values that are greater than the value you're looking at. Backward difference requires values that are less than the value you're looking at. As you can see within the formulae, they all require y are a function of the number you're looking at as well. But that's how you can land up thinking of it. So we can already see y of 1, we have no values greater than it. Nothing over there, but we have a bunch of values that are less than it. So we land up with, just going to do the color again. We have got y of I, so because remember in this case, we have decided that our I is over here. Let me put that in black. We've decided that this is our I because this is the point that we're interested in. So if we go back to our highlighter, we have got y of I, which is here, and we've also got it here. We need y of, we've got y of I minus 1. So we can immediately see that we hop over to, I want to get a color I haven't used. We can immediately see that these are all plus. So we don't have that, we don't have that, and we don't have that. So we can eliminate that from use. In this equation here, we can see that we've got y of I minus 1. We've got that over there. We've got y of I minus 2. And we've got y of I minus 3. And once again, we've also got h over here. H being our difference between. Once again, it's as simple as just plugging it into the formula and hitting equals on your calculator. This time I'm not going to land up writing it all out. I'm just going to give you the answer on this so we can move to the next one. And we get 1.8829. And it does continue, but that's all I'm going to be writing on this one. Again, if we wanted to double check, we can we know that the derivative of e endlessly is, or of e to the x is endlessly e to the x. This being the third derivative, we look at e and we take this to the power of 1, because that's what we're looking at. Anything to the power of 1 is itself, and 2.718 is the expected value. 1.88, yes, we're starting to be quite far off, But this is where you have to also bear in mind and start to rationalize. We're working with the OH over here, and OH has a large margin of error, if you remember from the Taylor series. It means that we are only considering essentially the first term in the Taylor series. So the amount of error we're going to see in an OH equation is going to be much, much larger than if the amount of error we see in an h to the 4 or h to the 2 equation. H to the 4 is going to have even less error than an h to the 2 equation. So now let's look at our final question. Okay, so we're looking for y prime of 3 over 8 to order h squared. So I wanted to focus on this one as well because it's got some unique elements in it. As you can see, over here, I have rewritten the table slightly differently. I have included our 3 over 8 into our table. Now, remember what the question said, using the values of the function for x equals 1, a quarter, a half, and 3/4 and 1. All of these other equations. But we have to bear in mind that sometimes we're going to be wanting to work out a value where we don't actually have the given x value. And we don't have the given y value for it either. So this is one of those instances. So because we've now introduced a new value into this system, something that's important to check is our difference. So I'm going to be looking at the x, but I'm putting this below to indicate what we're looking at. So a half minus 3 over 8. Well, remember, we're going to basically have 4 over 8 minus 3 over 8. That's 1 over 8, which is 0.125. Over here, it's still 0.25 and 0.25. Here, once again, 0.125 and 0.25. So given that we now have a difference of 0.125, 0.125, 0.25, and 0.25 for the others, we could also start looking like this. If we go from the middle to the outer one, well, this is going to be 0.25 plus 0.125 is 0.3. And then our difference over here is going to be 0.350. And then once more, we have the same difference here, which is 0.25. So this is just another thing that you can start looking at. Now, something to remember, if you have been given data, it is very important to remember the closer the values to on either side of your point that you're looking at. So we're looking at x is equal to 3 over 8. So remember with forward difference, we're looking at a number of them that are above it. Backward difference, we're looking at a number of values which are below it to inform what our value is going to be for the number in question. It's important to remember that the further away the numbers that you're using to approximate this value are, the further away that they are, the more inaccurate your answer is going to be. That's why forward difference and backward difference are going to be more inaccurate than your central difference. For the same reason, while we do have 0.125 and 0.125 on either side of this, and we do have 0.35 and 0.35 if we were to ignore the x is a quarter and x is a half value, well, we do have this as a scenario. We would much prefer to use these over here than these because of accuracy. Sometimes you'll find that you're going to land up with a 0.125 here, 0.5, and then 0.125. So, sorry, we'll have maybe 0.25, 0.125, and then we'll have 0.25, 0.125, in which case we're now stuck. The only way that we can get equal h on either side is going to be through the second one. But in this case, we see that we have got this over here and this over here, so that's what we're going to be using. It's very important to be considering this because you're not just looking at your eyes. because in this case, I'm going to be calling this I0. Now, 0.25 is 2 of these, so if moving 1 this way, if this is our I, then this is going to be our I minus 1, and then we jump 2 of them, so I'm going to say that this is I minus 3, because we've gone across by 1, then we've gone across by 2 in one jump. So I would call this I minus 3. If I minus 3 is 0, then I is going to be 3. So in that case, we have 0. Now we jump 2, so I'm going to put 2, 3, 4, doing the same principle in the other way, 4, and then I'm going to jump up by 2, I'm going to go 6 and 8. And the reason for this is all dependent on our xi plus 1 is got to be equal to xi plus h. If we have defined our h to be equal to 0.125, then, and we've defined that our xi is going to be equal to 3 over 8, which is equal to 0.375. Then moving up to here, we move up by 1h, then we jump 2 h's and we jump 2 h's. And then here we jump 1h and we jump 2 h's. So that's why I've numbered like this. It's always important to double check that, or you will end up making some mistakes. So next thing we need to do is pull up our table. Now that we've established what our i's are, we need to pull up our table. Now that we've got our table, I'm going to do the highlighting thing again. So I'm going to cover that, and I'm going to cover this over here. Just preemptively only looking at those two. So back to the question, it's y prime over there. Me use the proper highlighter. Y prime over here. So I'm looking at y prime here. We are looking at order h squared. So I'm looking at order h squared. I'm focusing on the central difference because I know that it's the most accurate. So once more, we can ignore the other ones. So here we have xi minus 1, because 3, well, we're going to consider this as our I. So 3 minus 1, we're going to look at this. So 1 plus 1, we get our 4. We've got that over there. So I can highlight that there. And minus 1 is going to be 2. We've got that over there. We don't require any other variables. So we're good to go because we also know our h is 0.125, which is here. And I'm going to put that in there. I'm going to write this one out because this is a slightly more complex one, just to completely cover it. So yi plus 1, we have got e to the half minus then we've got yi minus 1, which is e to the quarter. And if we divide that through by 2 times our h, which is 0.125. Punch that into your calculator, and you should get 1.45878. And it does continue. Again, let's double check ourselves. We weren't allowed to use the values for the point itself when determining this, but let's just double check ourselves. So we know, again, as I was saying, derivative is always going to be the same when it's e to the x. 3 over e to the power of 3 over 8. If we check that, we come out with 1.45499, and it goes on. You can see that these are very, very simple, very, very similar. So we know that our approximation here is correct. And I'm just going to put this e to the 3 over 8 is equal to that. We can say here e to the 3 over 8 is approximately equal to that.